Hello everyone, our next topic of this video series is data preparation phase to model the data. In this video we covers the topic to partition the data using Python, how to balance the training data set using Python, how to build CART decision tree using Python, how to build C50.0 decision tree using Python, how to build random forest. So first we discuss about what is data preparation. Data preparation is a critical step in the data science workflow that involves cleaning, transforming, and organizing raw data into a format suitable for analysis and modeling. High quality data is essential for generating accurate insights and building a reliable model. Data preparation ensures that the data is consistent, accurate, and ready for further exploratory or analysis. Next is key steps in data preparation. First step is data collection, second data cleaning, third data transformation, fourth feature engineering, fifth data integration, sixth outlier detection, seventh data reduction. Next is partition the data. Partitioning the data refers to dividing a data set into distinct subset for specific purpose, typically in the context of machine learning or statistic analysis. This steps ensures that models are trained, validate, and test on separate portions of the data to avoid overfitting and access their generalizable. Next is how to partition data is data how to partition the data in Python. Step 1, import necessary libraries, load the data set. Step 3, split the data. Step 4, check the shapes. Now we take example for how to partition the data in Python. We take a simple example for this. First, we import necessary libraries like sklearn.model, sklearn libraries, and then load the sample data set. Here we load the sample data set x.iris.data, x equals to iris.data हैश फीचर्स, वो फीचर्स के लिए मैंने लिया है और वाई लिया हमने टारगेट लेवल्स के लिए. स्टेप 1 होता है स्प्लिट द डेटा इनटू ट्रेनिंग एंड टेस्टिंग सेट, 80% train and 20% set. Step 2, further split the training set into training and validation sets, 80% train and 20% validation. Next is print the shapes of the resulting data set. We use the print statement for this. You can see, and this will be the output for this code. This will be the output for partition the data in Python. This is the simple code, and this is the output for this code. Now our next topic is balance the training data set. Balancing the training data set refers to the process of addressing class imbalances in the data, particularly in classification tasks. In many real world data sets, some classes may have significantly more examples than other, which can lead to based model predictions. A model trained on imbalanced data might favor the majority class and perform poorly on the minority class, leading this skewed result and reduced predictive performance for certain groups. Balance the dataset aims to either reduce the size of the majority class or increases the size of the minority class to ensure that the model has an equal or a proportional representation of each class. Our next topic is how to balance the training set in Python. Balance the training data set in is crucial in machine learning, especially when you have a imbalanced class. This can lead to a model that favors the majority class, neglecting the minority class. Balancing techniques such as oversampling, undersampling, or adjust class weight can address this issue. So we take a simple example for how to balance the training data set in Python. We take example for this here. This is the example for balance the training data set in Python. First, we import the necessary libraries like sklearn, etc. We import here. You can see the libraries in this code. And step 1 is create an imbalanced data set using make classification. Step and then display the original class distribution using print function. Step 2, split the data set into training and testing. We split this data set into training and testing. Display the class distribution in the training set using print function. Method 1, smooth. Oversampling. We use here oversampling in our code, method 1, and then method 2, random undersampling. Here you can see we use the method 2, random undersampling. And then we use the next method, class weight adjustment in classifier. You can see the in this code we use third method, class weight adjustment in classifier. This will be the output for this code. This is the output for balance the training data set in Python. Our next topic is uh, our next topic in this video is build cart decision tree. Cart classification and regression tree is a popular algorithm for building decision tree which are used for both classification and regression tasks. The CART algorithm usually partitions the data into subset based on feature value, creating a tree-like structure where each node represents a decision based on the feature, and each leaf node represents a class label for classification or a predictor value for regression. Next is steps in building a CRT decision tree. First step is choose a feature and split the data. At each node, the algorithm chooses a feature and a threshold value that best split the data into two groups based on impurity, reduce the variance reduction. Second step is repeat the process recursively. The process contained recursively until a stop critical meet example maximum tree depth, minimum sample per leaf, the node reaches per class distribution for classification or the variance in minimum for regression. Third is for last one is the tree. After the tree is fully grown, it may be pruned to avoid overfitting by removing branches that does not significantly improve the model. Next is how to build cart. This is a CART decision tree using Python. Step 1, build a cart decision tree. Step 1 is data preparation. Step 2, model training. Step 3, evaluation. Step 4, visualization. So here we take a simple example for this. Okay, here we take a simple example for building a CART decision tree using Python. First, based on classification using CART. First, we import the necessary libraries. You can see the libraries in this code. sklearn and matplot, etc. Step 1 is load the iris dataset. Here we load the iris dataset features and label, class. Split data into training and testing set. 80% train and 20% test. You can see in this code we split the data training into training and testing. Build the CRT decision tree classifier. And step 4 is make prediction on the test set. Step 5 evaluate the model performance accuracy. Step 6 plot the decision tree. We can plot the decision tree here, and this will be the output for this code. Classification accuracy equals 100.00%, and this will be the built CART decision tree. This is a decision tree for this code. You can see here, this is a tree for, this is the output for this code. Next is regression sampling using CRT. फर्स्ट वी पहले हम लोगों ने क्लासिफिकेशन के थ्रू देखा, और अब हम लोग रिग्रेशन के थ्रू एग्जांपल देख रहे हैं. यहाँ पे भी हम लोगों को पहले लाइब्रेरीज इंपोर्ट कराना पड़ेगा, जैसे sklearn एटसेट्रा. यहाँ पे हम लोगों ने इंपोर्ट कराई है. स्टेप 1 क्या होगा, लोड द डेटा सेट, feature and target. Step 2 split the data into training and testing set. 80% train and 20% test. Step 3 build the CRT tree. Default criteria is MSCE. Step 4 make a prediction on the test set. Step 5 evaluate the model, and this will be the output for this code. Mean square error equals to 0.5. Our next topic is build C5.0 decision tree using Python. You can see first step is import necessary libraries. We import the necessary libraries, for example sklearn etc. Step 1 load the iris dataset. Here we load the iris dataset. Step 2 split the data into training and testing sets. 80% train and 20% test. Step 3 build the C5 decision tree model. And step 4 is make prediction on the test set. Step 5 evaluate the model accuracy. You can see the example. See the simple example for building C5.0 decision tree using Python. Then our next topic is random forest. We discuss first we discuss about random forest. Random forest is a popular in assemble learning method used for classification and regression tasks. It operates by constructing multiple decision tree during training and aggregating their output, either majority voting for classification or averaging for regression. This approach enhances the model's accuracy and reduce overfitting compared to individual decision tree. Next is applications of random forest. First application is medical diagnosis, second finance, third is marketing, fourth natural language processing, NLP. Next we can see the simple example for random forest. Here you can see the simple example. First step is import necessary libraries. Here we import sklearn libraries, and then step 1 is load the data set. Here we load the data set, and then step 2 split the data into training and testing set. And step 3 create a train the random forest classifier. Step 5 make prediction on the test. Step 5 evaluate the model's performance. You can see we evaluate the model performance here, and this will be the output for this code. This is the output for random forest. Classification accuracy equals to 100%, and then this is the output for this. And we can see using regression, random forest for regression. Here is the example for random forest for classification, and we see the another example for regression. Here we import the necessary libraries, load the data set, split the data into training and testing, create a train that random forest regression, And then step 5 is make prediction on this test set, and step 5 evaluate the model's performance, and this will be the output for this code. Mean square error equals to 0.26. So this is all about today's video. Thank you for watching this video.